Okay, so in this clip, we're going to look at an equation and just go into a little bit more detail as to what the moles idea tells us about an equation and why we're doing all this with RFMs and masses of moles, etc. So if we take the calcium carbonate equation again, which we've been using for the mass and moles examples, but calcium carbonate is a solid, it's limestone, and a carbonate will undergo thermal decomposition if it is heated. That will generate calcium oxide, again another solid, but will also generate carbon dioxide. So thermally decompose to give off a gas. Now we've got an equation there, we've got three sets of formulae: calcium carbonate, calcium oxide, and carbon dioxide. And that is coincidentally a balanced equation. It's already fully balanced. And what we haven't done and what we don't do when an equation is balanced in this way is we don't generally write the number ones which would appear or not appear in an equation, because we assume it's a number one. But what that number one is telling us, or if it was a more complicated example, is a 2 or a 3, etc., is what that's telling us is that 1 mole of calcium carbonate, when it undergoes reaction, in this case thermal decomposition, it will generate 1 mole of calcium oxide plus 1 mole of carbon dioxide from the 1 mole of calcium carbonate that we started with. And that's what the balancing numbers tell us. Again, 1 mole of calcium carbonate generates 1 mole of calcium oxide, 1 mole of carbon dioxide. Cannot generate any more than that. Okay, law of conservation of mass, etc. And what we could then do is compare the relative formula masses of the substances. So in previous clip, obviously we calculated that the RFM of calcium carbonate was 100. We had 1 calcium, 1 carbon, 3 oxygens, obviously as we added those up. Now we do the same for calcium oxide. Again, we know that calcium weighs 40 mass number and oxygen weighs 16 from its mass number. There's 1 of each, and so we need 40 and 16 added together. That gives us an RFM of 56 for calcium oxide. For carbon dioxide, again, carbon would weigh 12 and oxygen would weigh 16, but as you can see, there's 2 of those, and so if we add that together, that will give us a mass of 44. Okay. Now in this example, it's coincidental because all the numbers are 1 that 56 add 44 is 100. But it's not always that clear cut. In this example, it is. But if we have all of these numbers ones, what the RFMs do is allow us an insight into calculating the masses and the actual physical quantities that would be generated from these reactions. So again, just to use random example numbers, if, for example, 50 grams of calcium carbonate were used, we could estimate that that would produce 28 grams of calcium oxide plus 22 grams of carbon dioxide. Carbon dioxide as a gas, but it would have a mass, it'd have a volume of a gas, but a mass of 22 grams. And we know from that, because obviously 100 to 50 divided by 2, and what that then allows us to do is use the same ratios to generate these other masses. Now this is one of the simpler examples because, as we've said, all the numbers on the balancing equations were ones. We will look at more complicated examples where we'll probably have to use mass, moles, RFMs equations more clearly, more often. But as an initial idea, the RFMs and the ratio of the RFMs give us a bit of an insight sometimes into the masses of the things that we have. Now it is no coincidence that 28 add 22 equals 50, because that is the law of conservation of mass in operation.